And looks like we are live. Hello everyone and welcome. Welcome to today's Bootcamp Week 2 workshop. Nice to see you. Here is Stefano, it's me, and hello Alex, welcome. How are you doing?
Hi Stefano, I'm very well.
Great.
So happy to be here with all of you. I see there are more than 100 of people watching us right now.
Yeah, that's great.
That's amazing.
That's great, and yeah, it's cool. But first, let's check that the sound is all right. So please, can you give me a thumbs up if you can hear me and Alex? We are live. Sounds okay. Very good.
Yep.
All good.
Very well. So that means
I think we are good to go.
We can start.
Yes.
That is amazing.
So, yes. Hi, everyone.
Okay. So, hello everyone and welcome. That's week 2 of our January, or I better say Learnery bootcamp, building applications with Apache Cassandra, building efficient data model with Apache Cassandra. This week is about data model. I hope you did attend our workshop last week. If you didn't, it may be a little bit rough experience for you today, but still with our help, you will manage to do that. And if you did attend the last week, then welcome back. So let's start. I'm Alex Voloshev, developer advocate lead at DataStax, and I just happy to be here and talk about Apache Cassandra and our distributed solutions to you, because I don't like speaking about myself. What really matters is I like efficient solutions and I don't like inefficient solutions. And today we speak about one of the most powerful database solutions in the world, Apache Cassandra, and how to build an efficient data model with it. And today with me, Stefano.
Yeah, hi everyone, I'm Stefano. I'm also a developer advocate at DataStax. I like distributed systems and I love Cassandra, and also I like to teach and to communicate. So this is why I'm here. And yeah, that's more or less it. You can see on screen my contacts. So please, you are very much invited to connect with me. And as far as I'm concerned, that's it. So let's start.
Yep, good. So, but we aren't the only two doing job for this workshop, because the whole developer advocates team worked hard to deliver this bootcamp to you. And there are some of our great friends and colleagues in the YouTube chat, in Discord chat, to answer your questions. If you are watching us live, then ask questions. And if you are watching this video recorded, that's still not too late to ask questions at Discord. What do we do today? First, few words about Bootcamp, how it works, what's the status, and what do you do next to get your success with the Bootcamp. Then, short week 1 refresh in just 2 words. If you attended last week, don't worry, it will take like 60 seconds. Then we will speak about the keys, because keys are very important working with data, and the approach in Cassandra is different to the approach you used to have in with relational databases. Then we will speak about partitioning, because partitioning is a real key to success with distributed partitioning databases. We speak about modeling methodology, how to develop an efficient data model step by step in very details. And then obviously, what's next? Quiz, your chance to win the prizes, homework, and what do we do next week? Week 1 going to be, well, it's not going to be, it's almost over already, but you know what? it's not too late, not too late to join. You still can watch the recording, do the homework, get your badge, and move forward working with Cassandra and the applications we are developing in this bootcamp. When week second right now is in progress, as you could guess. When next week is going to be week 3. This week we speak about the data model because it's a very important part for any heavy loaded application. When next workshop will be all about coding and working with NoSQL database. And week 4 is going to be about APIs and microservices, one of my favorite topics. Notice, every stream is done 2 times for 2 different time zones. That's the first run, and second run we will have approximately in 20 to 12 hours or something like that, maybe 16 hours. Okay, doesn't matter. Anyway, you know where to find this information, and with homeworks all together, as a result of this bootcamp, you will be totally able to pass your certification and get certified Apache Cassandra developer or administrator with, well, this bootcamp is mostly focused on developers, and become certified Apache Cassandra developer totally for free because it's all sponsored by DataStax. I love working in this company. So, attend one of our 2 live streamed workshops, same content, Wednesday and Thursday. We stream on YouTube, and our plan B is anything goes wrong with YouTube, we can switch to Twitch on the DataStax Devs channel. For the questions, you can ask your questions on YouTube, but primary channel for us is our Discord server, because Discord is stays with us even then YouTube stream is over. And for games, quizzes, asking you questions, and letting you win our prizes, we use Menti. You will have to do workshop labs. You will have to do some work outside of the lab. It's a bootcamp, and you are supposed to work even after the stream. We use different technologies, places from week to week. Next week it will be Gitbot. Some weeks it can be Katacoda, and what really matters, all of our materials are on GitHub published, so you can do them anytime, at night, in the morning, whatever you prefer, and when you are, what's your most efficient time to be. Complete the learning materials. Most of them are published at the academy.datastax.com, some of datastax.com/dev, and but again, the main repository for our materials are on GitHub. And finally, submit the homework with the link specified in GitHub, and you will be good. First attendees of last week already has got their badges, right, Stefano?
Yes, absolutely right.
Okay, good. So you can get 1 badge per each week if you complete the homework. But what really matters the most, if you do all the homework, you will be totally ready to pass the certification for Apache Cassandra developer in the end, and DataStax sponsor it, so it will be for free for you. Sounds like a very good beginning of year 2022 to become a certified NoSQL engineer. I like this idea.
Yeah, definitely.
So it's Menti time. Now we have to ask a couple of questions.
Very good. So I think that's now my turn to show my screen. And there we are. And let me start this full screen. So I have to move we have to cover our bases on the moon. Sorry about that. Now that's more like it.
And meanwhile, there is a question by Feligrey TV. Is Wednesday class different from that on Thursday? Content on Wednesday and on Thursday is the same, but maybe different speakers.
Yes.
Not this week.
Yes, so this is just to come to be friendly with more time zones. So, okay, I better disappear for a while. Sorry, I will disappear and show you the code in its entirety. here. Hello. You can hear my disembodied voice. Okay, so please, we ask you to join menti.com, to go to menti.com, maybe with your phone or in a different browser tab, and use that after entering the code. That will make it possible for us to ask you a few questions, which will first be just a survey to get to know our audience better. But later we will use the same connection for a little quiz. And the quiz, there will be prizes to the winners. So we invite you to keep the connection open after these first questions. Let's see. There are already several of you who joined, but I see you're still joining. So
we can start those questions.
Okay.
It's not a competition yet,
but
just set up questions, and we have a lot of things to cover today.
But we invite everyone to join Menti, because later there will be a quiz and you will be asked questions and you will be given a chance to win some prizes. Great. But let's start.
And please get back to the screen. I miss you.
Oh, right. Sorry. Absolutely true. Here I am. Through the magic of video editing, I'm back. Okay, so we would like to ask you a few questions just to know you. So first, where are you connecting from? You see, you can pin your position on this map. You don't need to be 100% accurate, just for us to have an idea. I see many folks from all around Europe. I would say most of it is either France or Germany, but the blob is too big and it covers now all of Europe. So India, US.
I see New Zealand.
South America, New Zealand, Africa.
Ooh, and that must be Brazil, yeah? Oi, galera.
Brazil, right. Alaska, maybe. Wow, there are really people from all over the world. Very good.
I see people from India joining us.
Yes.
Guys, we run this workshop 2 times for different time zones. Yeah. If this one is getting late for you, you can totally jump in on Thursday because it may be a better fit from time point of view.
Yeah, good point. Another point that I want to make is I see many of you are answering also in the YouTube chat. Obviously, we are happy to see the places spelled out, but don't forget that the answers in the YouTube chat will not go into the map. And that's even more important later because there will be a quiz, as I said. And if you answer on YouTube, your answer will be wasted. So please go to menti.com and enter the code you see now on screen, at least for later for the quiz. Hungary, so people from all over. Okay, let's proceed. So how many of you participated to last week? Okay, very many, because this is week 2, as Alex said, and we are all obviously happy to see new people coming on board. Welcome, but as we expected, many of you are just continuing your journey with Apache Cassandra and application development. So yeah.
If you didn't attend week 1, but you already know Apache Cassandra, then you are totally good to stay and go with us. We are going to do some incredible things today. If you didn't attend week 1 and you have no idea about Apache Cassandra, still no need to jump out because we prepared a couple of slides for you to stay more or less with us during the rest of the workshop, but take a look. It's a great technology. It's mostly probably the most powerful database nowadays. So if you want to be better as a software engineer or administrator, if you want to get a better salary and better job positions, then you are totally invited also to attend the previous week, which is recorded and available, and you even can submit your homework. It's still possible, and get your badge for week 1.
Yes, absolutely. So yeah, we will later give you a link to a repository, and this is actually a one single repository for the whole bootcamp, so you will be easily navigate to week 1, and there you will find links to slides, video, and everything. So please don't forget, if you're interested, to go to week 1 and catch up with the material, because it's really a lot of useful and cool stuff to know. Okay. Next question. Obviously, to those of you who were to week 1, did you do the homework?
Right.
I see a lot of yes. That's great. That's great. So
If you didn't attend, then you can answer no. It's
yes,
also fine.
that's okay.
There are a few dozens of people who already, oh my God, we are getting closer to 100.
Yeah.
Who did the homework. You are the best.
Yes. Well, we've been grading the homework throughout the week, and new submissions come in daily. So congratulations, well done. And I would say the quality of the submissions is pretty high, which say means we have done a great job last week. But most important, you have been doing a great job keeping up with that. But you can still go ahead and submit for week 1. So don't worry, and let's move on to the next question.
Yeah, we want everyone to be able to participate, even if you didn't, if you was busy or somehow, that's totally fine. You still can submit your homework. The form stays open.
Yes.
Don't worry.
I see that Joe remembers that I reviewed your work. Yes, I did. I remember you. So, yes.
And there is a great question. Yusef Elarin asks, so the badge mainly depends on the Google form homework, not on the DS201 exercises, correct? So that's a great question. I want to say a word on that. Take a look. Badge mainly depends on Google form homework, totally right. But, well, let's admit that badge is badge. And what depends on your DS201 homework is your exam. If you do your job well with DS201 and then later DS220, you will easily pass the exam and get your real globally recognized certification. If you just do the GitHub for Google form homework, but don't pay attention to the academy content, DS201 and 220, it will be much harder to you to pass the exam. So both matters.
Yes, that's a good point, because the ultimate goal is to get knowledge more than the badge. So yes. Now that's a very interesting question. What's your take on denormalization? So some of you are like, do you know what? And well, today's content is aimed mostly at you, so welcome. Now, someone is very much against denormalization. Someone else is a fan of it. It's the true way to go. And I see a lot of, moderate positions like, yeah, there are cases where it might come in handy. Other times, maybe it's not so much. And well, today is mostly about denormalization in a sense. So maybe you will be able to judge better, or anyway, to make a more informed opinion after these 2 hours. So
today, 7 people answered it's an absolute evil. And today I will play this game.
Change your mind.
As someone, I will play someone from a dark side of the force and try to bring you there. So maybe I will manage to persuade you what it's not an absolute evil, and sometimes it's necessary.
I see that Aaron says something in the chat that is very much true, but it's a secret. Nobody has to say that. So yeah, denormalization is also employed in relational databases, but nobody wants to talk about that because it's seen as a dirty thing that you do just for performance, secretly, without much publicity. But we are jumping too much ahead, so let's just stop here with the questions. Thank you for the questions, and please keep the Menti connection open, because later we will be using that again, as I said. With that, I think I'll jump back to your screen, Alex, if that's okay.
Right.
And there we go. I have to adjust ourselves to the moons again.
Great. So,
well done.
Let's start then. It's going to be week 1 refresh, just 5 slides, I promise, very short one. Apache Cassandra is a distributed, decentralized database management system, one of the most powerful NoSQL databases, one of the most scalable, from my point of view, the most scalable in the world, which is used by most of the top companies to handle their scale. It was originally developed by Facebook, and then used by Netflix, used by Apple, also developed, not only used by Apple and Netflix, Instagram, Uber, and many, many, many other. It offers an incredible list of very powerful features. How it works and how it's different from our databases. Data is partitioned. There is no way to store hundreds petabytes trying to fit them all, squeeze them all into a single server. That just won't work. So Cassandra partitions data over multiple machines into some groups called partitions, and that's one of the primary ideas to get. I hope you getting that. If you don't, then when later watch the week one, it will help. Data is replicated, and that's very important. Cassandra is used by the companies what require 100% uptime. They want to have 100% uptime, not like 999999. No, just real 100% uptime, and moreover, disaster tolerance. Without proper replication, you cannot get that. Also, data is globally distributed. So Cassandra's trademark is multiple data centers over the world, still building a single cluster. And each data center is active. So there is no thing like read-only data centers or read-only nodes. Every node able to dispatch any request. Speaking of that, Cassandra uses decentralized, masterless, or we better say peer-to-peer architecture. No single point of failure. Every node is able to process write or read requests. Doesn't matter if you have 2 nodes or 200 nodes, still every node able to answer any request. An application can contact any node. In case your application cannot work with node A, it will just switch to node B or even to data center B if you have multiple data centers. Behind all those features, one very important thing to understand. On the scale from bicycle and to Boeing, Cassandra is very much on the Boeing side. So all those amazing features is a shared responsibility. Cassandra will do its job, but if you don't do yours, it won't work. So that's very important for you to pay attention to this workshop, because the primary topic of today's workshop is how do you not fail with Cassandra? How do you reach success with Cassandra? So, ladies and gentlemen, fasten your seatbelts. We are starting. And first and primary topic for today's workshop, it's all about keys. Let's start with the smallest unit of data you usually work in Cassandra, or like you use it to work in relational databases too. It's a cell, it's an intersection of a row and a column, and it stores some data, your bank account numbers, your name, whatever. It's still a single cell. When a group of cells as a single structured data item in a table is a row. That should be not a new concept to you. I believe most of you have experience with relational databases, right? So let's move on. Then something new comes, what we discussed last week already. New item in data structure is a partition. It's a group of rows having the same partition token or the same partition key, and it is the base unit of access in Cassandra. Important. Stored together, all rows are guaranteed to be neighbors. You remember, speaking of partitioning, different partitions spread over multiple servers, but all the rows within the same partition stored together, so we can easily access them. And a table is a group of columns and rows storing partitions. So far, so good. How do we create table? You have seen some statements like that last week. So let's pay a little bit of attention to the things we are going to discuss today in a bigger details. This statement by itself looks quite familiar to those who has experience with SQL, because SQL is designed to be very similar. Create table, and we have to specify table, and we have to specify key space, which is a group of tables. We have to give column definitions, TT, last name, first name, address, all in this case type text, but we have more data types than just text, believe me. Then there are some differences coming. Primary key, partition key, clustering columns. That's what we're going to talk about that today. What is a partition key? What is a clustering column? How do I build primary key and why you should care? First thing you need to learn, and first thing we discussed already last week, is a partition key. Partition key is an identifier for a partition. It consists of at least one column, may have more if needed, and this one and only job is to partition rows, and it also plays it part as a part of primary key we will discuss later. Let's take a look at the examples. In this case, you remember we use partition key to partition data, or better to say not we, but Cassandra. And how many partitions we will have when we have partition key like that? As many users we will have, and that's perfectly fine. We can have a lot of partitions. This primary key is totally fine. If we speak about commentaries on YouTube, that makes sense to partition them based on a video ID. So comments to the same video ID will be stored together, so we will easily retrieve them. You open YouTube page, you get your video and comments to it in a single request, not in a bunch of them. And finally, we can have multiple columns as a part of a partition key. For example, in this case, we partition our users not based just on a country, but on a country and city. As a result, we will have as much partitions as we have cities per country with our users, of course, then. Well, we discussed it already first week, so let's move on. There are some clustering columns, and clustering columns are very, very, very important. Clustering columns have two duties. First of all, they are used to ensure uniqueness. For example, take a look at the first example. What would happen if our users by city will be based just on a city? It won't work. If we drop clustering columns and use just city, we will have one user per city, which sounds a little bit like a Fallout disaster maybe to me. So when we go for city, last name, and first name, will this design work? You see already, it will have some problems. Clustering columns are responsible for uniqueness as a part of a primary key. And if we use just like city, last name, first name, then every next John Smith in New York will make a big disappointment for the previous John Smith, because he will overwrite data of a previous John Smith, as long as you don't use lightweight transactions, but we don't speak about them today. So what's the right way to think about the uniqueness using clustering keys? We go with city, last name, first name, and email. And we don't really need email in this case as a primary key. We want query based on this email, but we will use it just to ensure uniqueness of the key. So even if we have 20 or 30 John Smiths in New York, I believe most of them have more or less unique emails. Let's hope. But there is a second job of the clustering columns. Very important to understand what clustering columns define sorting order. So, for example, if you want to store comments for a video, and we could go with a key like that, partition key video ID, clustering column comment ID. Will it be unique? Yes, it will, because every ID is unique. But this design will have a little problem. They won't be sorted. And when we load comments for video, we want to see most recent first. And then we using created add column as a part of a clustering, column groups. We will, as a result, have our comments sorted by time. And when we retrieve them, we don't even have to execute sorting statement because they are already sorted by default. That's a very nice optimization. So two duties of a clustering column: ensure uniqueness and establish sorting order. They are optional. If you don't need them, you can go without them. For example, here you see the example of a key having 0 clustering columns, and that's totally allowed. But you cannot define anything without a partition key. You need always to have partition key. And then primary key, as you could guess, basically groups those two together, partition key and all of the clustering columns, if any, building together something which should be truly unique. So in this case, we have primary key of city, last name, first name, and email. Or here we have primary key of just a user ID for just a user's database. That's a primary key, something what unites together clustering columns, and a partition key. Primary key is an identifier for a row, and it's obviously required. You cannot create table without a primary key because you won't be able to retrieve any data of that. So it makes no sense. Primary responsibility of a primary key, one and only, is to ensure uniqueness. Now, why keys are so important? Take a look. There is a lot of power in Cassandra features, but there are also some restrictions you need to know because there is always price to pay for such a power. And very important limitations we have to discuss today. Let's take a look. Can you execute a statement like select all from users by city where last name equals something? Can you or cannot? I hope you got the idea, but if you didn't, then listen. When you are retrieving data and you have petabytes of data over hundreds of servers, maybe thousands, you need always to specify the partition key. That's an absolute must. So you cannot retrieve data just by last name because you have to specify city and last name. And how do you modify this statement to get your data? Where city equals something like, let's say, my hometown, St. Petersburg, Russia, where city equals St. Petersburg and last name equals something Ivanov, then you will get your data. That works. But this statement doesn't work. Now, can you retrieve a statement like that, where city is bigger than something, or city bigger than something and smaller than something? Will it work? No. Why? I mean, you are giving city, yeah, right? You are specifying city for any kind of integer data or string data that won't work, because partition keys always require full equality, not inequality, not range, but always equality, or in the worst case scenario, in statement. So it can be like select all from users by city, where city in St. Petersburg, New York, London, Ivrea, hi Stefano, and so on. So yes, in is kind of a strict statement, strict and equivalent. But you cannot use inequalities, not equals to something, and so on. You need to explicitly define your partitions, otherwise that won't work. Because if you don't specify a partition, we will have to do what? Full cluster scan. And full cluster scan is not something you want to have on your production. When you must be curious, what's wrong with the next statement, where city equals something, predefine it, and first name equals something, and emails equals something. We're specifying city, right? Then why this statement won't work? Because if you are using clustering columns, you have to give them in the order they are defined. So if you retrieve data where city equals something, and last name equals something, and first name equals something, and emails equals something, you will get your data. If you just get it like city and last name, it will work totally. But if you do city and first name, won't work. You skip last name, you will get an exception, right? And basically the same here. City defined, last name bigger than, okay, you can use inequalities on the clustering columns, that will work. And first name equals something, Like that is already sounds better. Good. So, what's our story here? Cassandra is dedicated for high performance on a high data volume. But if you will try to use it and search an analytic engine, you mostly probably will be a little bit disappointed. As we always say, as Cassandra is so good in a fast and performant big data queries, you may need to partner it up, team it up with other solutions like Apache Spark, like Elasticsearch, like Solar, to get also search capabilities over your data. Speaking of keys, I will give you a hint. We do not use sequential IDs in Cassandra. Try to think why, and I will give you 5 seconds to try to answer. Okay, 10 seconds. I'm very kind today. Why don't we use sequential IDs in Cassandra? Please answer. Right, Sylvain Leclerc. That is Youssef. Okay. So, partitioning is not the right answer in this case. But I see some people gave already right answer. So let's switch to the next screen. Why don't we use sequential IDs in Cassandra? The idea is when you work with traditional single host based databases like MySQL, Postgres, and many others, you can use something like that. Create table, column 1 integer, not null, auto increment, and then you can just insert something into your database and get your last insert ID. So it will be last value plus 1. That's actually quite convenient feature. I kind of miss that. But it doesn't work with Cassandra, and I see some of you answer it. Cassandra is distributed. Issuing sequential IDs will require collaboration of all the servers responsible for this table, and there can be 3 servers, or 30, or 300, or maybe 3,000, and it will require all of them to agree on what's the next number. Can you imagine storing your data in your database and then waiting for half an hour for all the servers to agree what's the next sequential ID? Because you don't want to have same ID issued to 2 different rows, right? Of course, right. Then how do you get IDs for different entities in Cassandra? There is a thing called UUID, Universally Unique Identifier. And this UUID is usually generated on the application side, not on the database side. And it's a very long string of different numbers and characters, which is universally unique. And the chance for them to have a collision is, let's say, it won't happen. So, working with Cassandra keys, you generate a universally unique identifier at the application side and then insert this data into the database, and your application already knows this ID, so you can go and work with it already. And those, as you see, are very 2 different approaches. With Cassandra, you prefer universally unique identifiers instead of sequential IDs. It's much more efficient, obviously, for the distributed, decentralized databases. And why cannot you afford centralized database? Because centralized database is a single point of failure, and Cassandra has none. So we just covered keys, and now I have to ask Stefano, do we have any good questions on the keys we have to discuss live?
Well, there was, can you hear me? Yes. There was a question about the 5th example of the forbidden queries, the one with, if I'm not mistaken, an inequality on the first clustering column and an equal sign on the second clustering column. because that was a bit surprising to some that this is not a good query. So I don't know if you want to go back to that one very quickly. Maybe it's one of the.
You want me to switch back to a previous slide?
If we have 1 minute, maybe it might help.
Yes, of course.
The forbidden queries, the invalid queries.
Here we go.
No, not too much. Here. Yeah, the fifth case. Why is the last red line a troublesome query? That's because there is within the partition, because there's an equal sign in city, so that goes to select a single partition. And as it is written now, there is an inequality in last name. That means if you think about how the rows are sorted within the partition, that means that still goes to read a sequential block of rows within the partition, but then due to the equal sign on first name, that implies a jumping pattern in reading the partition. So the way it is, that would raise a problem. Now, still, as Cedric remarked live on Discord, still, this is not a bad pattern in itself, because the important thing is that you go to a single partition. But then this is one of those particular cases where you can use allow filtering, and that's not like, you don't go to jail for that. But you still need to explicitly allow filtering in this case, and you will be reading a single partition, but in a leapfrog kind of way. So that's a bit of a corner case. That was a question by Youssef, I think, if I'm not mistaken. Yeah. So that's it. The rest,
okay.
Yeah, there have been a few questions, but they have been answered. So yeah.
There is a question from Youssef, but I'm not sure I get the question. I'm sorry. One at the end only, or even once in the middle. All the queries here are wrong queries. So inequalities for partition keys are not supported at all. And in this case, inequalities per se are supported. So take a look. The last query, where city equals something, and last name is bigger than something, this statement will work. But together with first name, it won't work. You can have inequalities or on clustering columns. There is just a restriction what doesn't work together. Inequality on first one and equality on the next one. That's what won't work. So let's move on. We are done, Stefano, right?
Yes, I think so, yeah. So, okay, I see a few more questions, but maybe we better ask you to go on Discord.
We better discuss them later.
Yeah, we have so much to cover.
We better discuss them later on Discord.
Yeah.
Okay, so partitioning in details. And if it's late for you and you are going to leave, stop. Focus on what we are showing, because next slides are the most important slides for you in year 2022. You won't see anything better in the year 2022, I promise. Because Cassandra is partitioned, the key to success is to do partitioning right. If you do partitioning right, it will work most of the time. If you do partitioning wrong, well, that's the easiest way to fail with Cassandra. And I want you to be successful. I want you not to fail. So pay your attention. We are going to make a deeper dive into rules of partitioning. And there are only 3 rules, very easy to remember. You need to know all of them, and those are simple. Store together what you retrieve together. Avoid big partitions. Avoid hot partitions. Let's start step by step. Store together what you retrieve together. I briefly mentioned that already. What you tend to retrieve together from the database as a single query, you better store together. For example, our typical use case, we open a video on YouTube, we see all the comments, most recent first, in one single query. Do you want this query to be executed to ask multiple different servers? No, you don't. You want this query to be executed very fast. And of course, it's much faster when you need to ask only one server. Then that totally makes sense to keep all your comments to a video as a single partition. How do we do that? We decide on the proper partition key. So for all our comments to this video you're watching right now, you go with video ID as a partition key, and you are done. So they will be stored together, very simple to follow this rule. Take a look at the second example. Imagine we have a table for comments partitioned by comment ID. As a result, it will have as many partitions as many comments you have. Is it bad per se? No, it's not a big deal. You can have a lot of partitions. But will it work well for the query, give me all comments to a single video by video ID? That just won't work because you do not specify video ID. Video ID is not a part of partition or a clustering column, so that won't work anyway. But even if it would, you still will have to ask most of the servers of your cluster. Maybe you have comments for the video number 13. No, you don't. Okay, I will go ask next server. Thinking of a YouTube size of the data, how do you think, how much time it will take? You don't want to use YouTube if they would use this approach. So obviously, store together what you retrieve together in a single partition. You know what? Second rule contradicts to the first one. Avoid big partitions. Well, I don't really prefer to think of it like contradicting, but adding a restriction you do want to consider. Avoid big partitions. Do you remember why do we do partitioning after all? To avoid too many data per server and to support easy, simple linear scaling. When your partitions are getting too big, you basically running into the same problem we were avoiding with introducing partitioning. After all, your database cannot be fast if you have too big partitions. So what do you want to have? You want to have limited size partitions. And there is only one hard limit. You cannot have over than 2 billion cells per partition. It's a hard limit. You cannot cross it. It just won't work at all. But our recommendations, like DataStax, Cassandra best practices, are significantly smaller. We recommend not to have more than 100,000 rows per partition, and we recommend not to have more than 100 megabytes per partition. Those are soft limits. Those are recommendations. If you go to 101 megabyte per partition, you don't have to cry too loud about that. It's not a disaster. We've seen some people with partitions like 1.5 terabytes. That is definitely a bad idea. Speaking of examples, if you're having a table like country, user ID for users, so your users partition it by country, it's quite a bad thing because you may have, in some countries, you will have, I don't know, Monaco or Vatican, you will have very small amount of users, but in companies like India, like China, you may have really a lot of people, and that's obviously not going to work well. What you want to have with partitions to have them reasonable size and more or less the same size. So think, how do you partition your data? On the example a little bit upstairs, comments for video, then take a look. You might say, what, hey, Alex, there are some videos what may have really much more than 100,000 rows. That's technically right, but take a look. Comment, as it is quite a small entity. It will have user ID, username, because we go for denormalization, comment ID, timestamp, comment text. Basically, that's it, 5 fields. Well, okay, 6, 7 fields because there are some more data to store, but in general, the idea is that's it. So each comment is just a text value of quite a small size, as long as you don't allow to write comments like war and peace. And we wouldn't recommend that. So In this case, comments per video can survive this limitation. In general, you may think of a better partitioning key for comments per video, still paying respect to the first rule, which is store together what you retrieve together. But let's move on. You also have to avoid hot partitions. What that means? Let's take a look. What's it about big partitions? It's about their size. It's about their disk space they're consuming, basically. And what is a hot partition? Hot partition means one partition being accessed all the time, and some partitions are not being accessed at all or being accessed significantly lesser amount of any interactions with them. And maybe quite a good example of users table having partitions as much as users you have. Well, that's totally fine. You will have a lot of partitions, one row per partition, and that works. Usually your workload is distributed over multiple users, and normally you have a lot of users, especially if you use Cassandra, so that's fine. Thinking of videos, it may be a different scenario, because there are some videos what no one is commenting, right? And there are videos like ours with a lot of comments, or also there are videos from some stars, top stars, getting millions of comments per day. Obviously, some you may say what a partition from some, I don't know, top star is going to be hot partition, but let's think. As long as this partition is not too big, and as long as we have many partitions, if at some point we get too high pressure on this partition, we can add more servers. Partitions will be spread over bigger amount of servers. Therefore, we will have as a result smaller amount of partitions per server, smaller pressure on server. As long as a single server can handle single partition, you will be fine in the end. You just need to have multiple partitions. But if you have only 10 partitions and you have high pressure on one on them, like really highest possible pressure, like you are doing some e-commerce and you went to China and now everyone is buying to you, like you got some huge success. And you have got 10 servers before, but now your system is overloaded because obviously everyone is buying from you. First of all, congrats, but now you have a big problem. Your system is overloaded. You may tell me, hey, Alex, we are successful in China. Everyone is buying from us. I mean, we have money. We can buy, I don't know, 1,000 servers if we need to. Yes, you can. But think of what? If you have only 10 partitions, 10 countries, and one of them are overloaded, and you have 10 servers. If you add 10 more servers, will it help? No, because partition is the smallest unit of access, base unit of access. And you cannot divide partition in two without migrating data to a different table. So as a result, avoiding hot partitions when one is overloaded and all the others are resting, and this one is too much, that is definitely very, very, very bad idea. So think about data size, volume distribution over partitions, but also pressure workload distribution over partitions. And now I have a good question to you. I like to make you thinking. Danger is not always obvious. What's wrong with the next model? Take a look. Together, we all work in a huge telecommunication company. Very huge. It's a real use case, by the way, from real life, real world. It happened with one of our clients. Imagine huge telecommunication company, like one of the biggest in the world, with a lot of infrastructure and with the data centers all across the world. And there is a very huge Internet of Things network with very, very many, maybe billions of different sensors reporting their state every few seconds. every sensor, every few seconds, returns its timestamp. So what's a local time? Its own ID, of course, and the current sensor value. What is the sensor value? Doesn't matter right now. It can be temperature, it can be humidity, it can be a door sensor, door is open, door is closed. So basically Boolean value, true or false, and so on. So each sensor reports UUID, you know what that matters already, timestamp, and a value. And we have to store such data. And in the beginning, we designed a table with partition key sensor ID, because rule 1, store together what you retrieve together. And we want to see the data from a single sensor, of course, to see how temperature in the room changes over time, right? And then report it as a clustering column to sort data by time and to keep uniqueness, right? And this design works. I mean, it works. But after some time, we start to notice some heavy problems with our cluster. Now, that is a question. What happened? What went wrong? And what's wrong with this design? Please answer in the YouTube chat. And Joy Diaz says we are missing reported time, reporting location, sensor type. Timestamp is the reported time, and sensor doesn't know reporting location. It knows only its own ID. And sensor type we just skip for clarity.
I see the question. The right answer has appeared in the chat.
Right.
Yes.
So right answers were given already. It will result in 2 big partitions. Take a look, Amit. Amit says lots of report at the same time. I see people with relational databases, disappointing experience, right? With other databases, you may be afraid of too many pressure per second, lots of reports at the same time. But with Cassandra, which is perfectly scalable for writes, you only have to take care of having right data model and having enough servers. And if you have enough servers, you will easily handle any kind of pressure. You can handle, like Apple does, like Netflix, Instagram are doing, you can handle dozens and hundreds, millions of operations per second. Hundreds, millions of operations per second. So it's not about amount of reports per second. That is totally fine for Cassandra. But the real point is what your partitions will be too big in the end, not in the beginning, but they're growing every 10 seconds, more and more and more. So after a few months, your partitions will be just too big. And there is a point, volume gets increased quickly by JB Akash Perumal. It's also totally fine. You can have huge volumes. You can have petabytes volumes. You just add more servers. Cassandra handles that. So with Cassandra, you shouldn't be afraid of the things you're normally afraid of. Too many reports per second, too big data volume. This is not a problem anymore. But you have to think of your partitions, right? So many correct questions. That's amazing. Now, let's think what is the what would be a good solution for that? Sajal thinks in the right direction.
Very good.
So in general, there are 2 typical solutions for this situation. First one, call it TTL, time to leave.
And there it is,
Cassandra,
in the chat.
Yeah, right. Jitesh, I see a man of experience here.
Good idea.
Yes. First solution, obvious solution, is use TTL, time to live. With Cassandra, when inserting data, or even inserting not just the rows, but really particular values, you can configure time to live. And you can say for this record, I want to have TTL 10 days. And it will be automatically deleted after 10 days or after 10 years, whatever you said, and you don't have to worry about that. That's amazing. Now, in this particular case, because as I said, it's a real case from a real life, it wasn't the option for us because this client wanted to keep this data for a long time because maybe of some audit requirements or anything. But well, TTL was not a good case in this situation. There is another solution, much better solution. It's called compound partition keys or bucketing. Take a look on the update. Instead of using just sensor ID as a partition, we go with sensor ID and month of a year as a partition. Then partitioner, hasher, get these two values, bring them together and produce a token. As month changes, you will get a new token and therefore new partition will be created. Take a look, what is a month year? Month year may be an integer or a string, that doesn't matter. And let's say it's going to be January of 2022, right? So in this case, month year will be 012022, or it may be opposite way around 202201. And then January is over, new month year will be 022022. So year, month, and year. Therefore, new partition created, and never partition, never written again, which is quite cool. So it's called bucketing because we are adding a synthetical field to the partition key. And now we can have our data written to that only for the particular month of a particular year. A new partition will be created. As a result, we will have more partitions of a smaller size. Now, yeah, it's a composite key or compound key. There are multiple definitions, but the general idea, it is a bucket for data. By the way, I noticed a comment there we will have too much partitions because we will have a lot of sensor IDs. And in this scenario, we will have even more. It is totally fine. With Cassandra, you may have as much partitions as you want to. Stefano, fix me if I'm wrong. There must be like 2 in the...
I think it's 2 to the 64
2 to the 64, right?
Available.
So that's quite a lot.
Yeah.
Let's say
big number.
It's enough for you. Yeah, good. And now one more question. Someone said to make buckets based on the day, like first day, second day, third day, and so on, like counting days. Will that work? Let's think. I cannot find this comment. I cannot find it, but doesn't matter. So if we go per day partitions, it was said by, my God, now I cannot find it. Sajal Gayal. So per day partitions, will it work on the write time? Yes, it will work on write time. You write data, you give in a partition not month, year, but day, and that will work. But think of that. We not only store data, but we also retrieve data from time to time, right? And when you retrieve data, don't forget you have to always specify what? All the parts of a partition key. And let's say I want to see data of a particular sensor for last 3 months. How will my query look like in this scenario? It will be the sensor ID equals 1, and month year is January 22 or December 21 or November 21. in statement. It will require to access 3 different partitions. It's not a perfect scenario, but it's also not so big problem. We can do it. It's fine. But if we give day by based buckets or hour based buckets, and you have to show data for the last 3 months, can you imagine amount of servers we will have to access, amount of partitions we have to access? With days, it will be around 90 something, and with hours, I won't even calculate, but it's going to be much worse. So that's obviously not the best scenario. That's the answer. Avoid big and constantly growing partitions, and you can use TTL or bucketing to avoid constantly growing partitions. But that's very important for you to remember what partition may grow over time. So, Stefano, do we have anything important to answer, to comment right now before we go to the next slides? You are muted.
Sorry. After learning about TTL, Joe is asking, what do we do if we want to archive data out of the table, but still not having it quietly disappear? So are there any solutions to bulk archiving data? Well, I think there are a few. It depends on the format you want to archive data. What you can do is to periodically send to an object storage like a Glacier. You can send your raw files containing the data, for example. That's a very low cost in terms of technical setup. Or maybe you can think of a Spark job to periodically take a snapshot of all of part of the data and send it to a different cold kind of storage. I don't know, Alex, what would you suggest in this case? You can maybe
first of all, yeah, no, it's all good. If we want to archive like with backup purposes, easiest way to do it based on the SS tables files. Yeah. The point is this is a part of administration course, so it's not the topic for today, but if you're asking, I'll answer. The story is Cassandra is designed to be extremely performant. And one of the ways to reach that is basically immutability of the data. It's a hidden secret of Cassandra, and now you will learn that. Maybe I've mentioned something like that this last week. Create, insert, update, and delete are basically all the same operations because Cassandra is append only. And as a stable files for sorted strings we store data on disk are totally immutable. Once it's created, it never will change. It makes backup of the data or archiving of the data very, very, very convenient. You just grab your as a stable and put it to a cold storage like AWS S3 or Minio or whatever you use, and OpenStack Swift, and you will be good with that totally. So easiest way to do it is to do it based on the as a stable files. If you want to have more granular control, you may need to use Apache Spark, DSBulk, or tools like that. And I hope I've answered this question. One more thing I wanted to mention, question from Pavel. Does the composite key data store it in the same node? One more time, how does data is partitioned? Based on the partition tokens. How does token calculates? Based on the partition key. If you have 2 rows reported on 1st January and 2nd January with the same sensor ID and with the same month year, let's say sensor ID 1, month year January 2022. They will have, as a result, as they have same partition key, they will have same partition token, they will group the same partition, they will be stored together. But if anything changes, sensor ID or month, where token will be different because of a hashing algorithm murmur-free, and as a result, they can be stored on a different server totally. Are there any more good questions?
Well, there is something more about TTL and tombstones, but I think again we are better going forward because that goes a bit too much into the details of storing, physical storing of data. So maybe again we would probably direct you to speak more on Discord for that. I don't know.
Discord, or better, if you really want to understand internals of Cassandra, you may think of taking DataStax Cassandra administration course on the Academy. It's free. And meanwhile, by the way, if you are into administration too, don't forget what voucher for certification we give with 100% discount. It's valid for 2 attempts. So if you take your DS2-1 course and you take your DS2-20 course, which we will do during the next week, and you go and pass your exam from the first attempt, becoming a certified Apache Cassandra developer, you still have 1 attempt left, so you can go and learn DS2-10 for administrators. And then with the second attempt free, you can try to take administration exam. And as a result, you will have 2 globally recognized certifications out of 1 bootcamp. And that is a real advanced scenario. So please then let me know in Discord or on LinkedIn, and I will applause to you and put you and mention you in LinkedIn, that's for sure. To get 2 certifications from one bootcamp, it's really like advanced achievement.
Yeah.
Good.
Good.
Good. And a question asked by Manikandan, we answered that last week.
Yeah.
There is a logic for partition token, how it's stored, but we won't discover that during this level workshop.
I gave a short account, but please go and have a look at, because that topic is examined in a bit more detail in the contents of last week. Or as Alex said, in the course again.
In short, it's not your headache. It's not your headache, it's Cassandra headache. Your job is to make partitions even and equal, more or less even and equal in the size and the workload distribution, and you will be good. Cassandra will take care of the others.
Yeah.
Good. So, and we are getting to the very heart of this workshop. Modeling methodology. We will learn to build efficient data model with Apache Cassandra. But before, we have to realize 2 very important things. And first thing is denormalization versus normalization. There were 7 people who told what normalization is good and denormalization is an absolute evil. And now wait for it, we will discuss it again after a couple of slides. But before we start, let's talk about what is the normalization and what is the denormalization. So when we will discuss benefits of each approach. What is a database normalization? Normalization is a process of structuring data in relational database in accordance with so-called normal forms with the purpose to reduce data redundancy and improve integrity. It was proposed by Edgar Code in like 50 years ago first. So basically, if you have employees, if you have employee management system, and you have employees working in different departments or teams, you don't have the department name in employees table. You have 1 table for employees, you have 1 table for departments, and the department name stored only in the departments table. And in the employees, going on. Oops, sorry guys. Something happened with my Chrome. Good. And employees don't have anything about departments, but they have user ID, department ID, first name, last name, and then department ID is the lead to a proper department. So we see what Edgar Code work in department ID 1, so we can go and see what department ID 1 is actually an engineering department. That's it. There are some normal forms defining rules, like the deeper you get into normalization, stricter the rules on how do you normalize your data. That must sound familiar for most of you, based on the recent Menti question. So, what are the benefits and what are the disadvantages of normalization? Now, some of you must be like, what do you mean disadvantages? Normalization is perfect. It has no disadvantages. No, normalization is just a tool. And as every tool, it has some good sides and some not good sides. Is Hammer a great tool? Yes, totally. Hammer is a great tool. But if you have to, let's say, take a look at some bacteria or amoebas as a part of biological research, is Hammer still a good tool? Yes, Hammer is still a good tool, but not in your use case, right? As with that, we have different use cases in software development, and there may be some better approaches. So, what are the benefits of normalization? First of all, it's a simple right. When you need to rename a department, or when you need to change data anyhow, if you want to insert data, you need to do just one single simple right, right? So it's basically a simple thing. You need to update something, change something, you do one simple short right. Second serious benefit of a normalization is data integrity. Data integrity means what? You can have all the benefits of relational databases, foreign key checks, on-delete cascade, and other data integrity checks, helping really a lot working with your data. But what are the disadvantages? First of all, slow reads. And you can tell me, hey guys, hey Alex, I have my MySQL with my internet project running, and I'm getting my reads very fast. Of course, you can have your reads executed fast as long as your data fits into a single server. But when you go to from kilobytes or megabytes of data, you go to terabytes, petabytes, data is spread over multiple machines, your reads are not going to be as fast anymore. And basically, you will have to go with sharding, and sharding destroy your joins completely. So, slow reads, I insist on that. In comparison with denormalized reads, that's for sure. And second thing are complex queries. One little bit unusual questions. I ran once into an interesting limitation doing some development for one German company. I got a very interesting exception. How do you think how many join statements you may have into a single select statement in MySQL version 5? It happened some years ago, so it was version 5, I believe. How many joins you can have in MySQL in a single select statement? Try to guess. Give me a number in YouTube chat.
Drop a hint. It's not a power of 2 for some weird reason, as you would expect.
5, 64.
Not a power of 2.
Yeah, it's not a power of 2. Much more than 5. A little bit less than 64. This number is 61. No, not 67,000 for sure. 61 join. Can you imagine main query with 61 joins? I've got some PTSD at this project, that's for sure. And it was very hard to maintain such a query. So joins are great, but joins have some disadvantages. And the biggest disadvantage of the joins is not shown on this slide. I will show it to you on the next one. But first, what is the denormalization? Denormalization is a strategy used on a database to increase performance, not data integrity, not data reduplication, but performance. In computing, denormalization is the process of improve of a read performance of a database at the expense of losing some write performance by adding redundant copies of the data. Take a look now. I have my employees table, and the department name is stored right in the employees data. That is a denormalization. Data is duplicated. Notice I still have department tables with department ID, department. I still need that for other purposes. But now, when I retrieve data, I don't have to do joins because I get department ID directly from the employees table, and I don't have to do any joins to get a profile of my colleague or my employee. And it brings some very serious advantages. First of all, quick reads. Now I do not have to execute any kind of joins on the read time. I just go get my data, show it on the screen, boom, done. Second benefit are the simple queries. No joins, right? Every query is a simple query. I have user ID, first name, last name, department, it's done. As long as I know user ID or first name, last name, I will get the data of this employee. We are totally fine. So quick reads, simple queries, much easier to maintain. But as again, a microscope is a great tool, but there are no perfect tools. It all depends on your use case. And there is always price to pay for that power. What is the negative sides of the denormalization? You know that already, right? Multiple of rights. So for example, if I want to rename engineering department into something, let's say black magic department, because engineering sometimes looks like a black magic, then we do what? We have to change department name for department tables and for each engineering employee in the table of employees. So we basically have to do multiple writes, right? Yeah, right, Rock Pereira, data duplication. Denormalization means data duplication. So we have to do multiple writes then changing data. And second point, as it's a denormalized data in non-relational database, we cannot have all the foreign keys checked. We cannot have on delete cascade. We cannot check on the foreign keys. All the integrity, cross-table integrity is to be maintained by application developers. So integrity is to now a thing of a manual support. And you can say that's quite a high price to pay. And yes, it is. I won't lie to you, it's a high price to pay. But what's the point? As I told you last time, Cassandra enabled developers are getting higher salaries. As long as we get more money for that, I can survive manual integrity support. But there is one more thing, secret thing, which changes much more. I will share it with you, of course, because you are the best, you are attending our bootcamp. Let's think, when I have to get data with joins using normalization, and I have a table, what depends on a table, what depends on a table. Very common case when you have many-to-many relations. Can database internally run those joins in parallel? Like if I have to do 3 joins, can I do them in 3 parallel threads? No. I first have to do first join on next available table, get some data from it, then based on this join, I have to do the next join, and then based on the next join, next join. So the story is, for most of the cases, you cannot, database internally cannot execute those joins in parallel, and as a result, they can be executed only sequentially, one by one, by one, by one. That means slow. Just slow. And let's think. can I execute with denormalization multiple writes simultaneously in parallel? Answer is yes. Because we don't depend on each other, we go to different tables. And the amount of writes grows significantly. But I told you already, Cassandra is a very good fit for very huge write workloads. Cassandra scales perfectly for writes workloads. You don't have to worry about that. Every node is a master node. So every node can handle write. If you have too many writes, add more nodes and you are good again. Cassandra power. So I can execute multiple writes in parallel, but I cannot execute multiple reads, joint reads in parallel. As a result, denormalization is significantly faster for all these kind of scenarios because writes can be executed in parallel and joins cannot in most of the cases. That's the story of normalization and denormalization. And those 7 people, glorious 7 who answered what denormalization is an absolute evil, please let me know in YouTube comments if I managed to persuade you what it's not an absolute evil. And sometimes it's a required tool to reach performance from your applications you want to have. So it was the first thing. But where is the second thing? Most of you have experience working with relational data. And you know how data modeling for relational databases usually goes. Relational data modeling or traditional data modeling. First, you analyze raw data, domain, entities, their properties, relations, and so on. Then, based on the results of this analysis, you design tables using normalization, foreign keys, and relations for those entities. So we go from raw data from the domain, we go to the table design, and then when working with this data, we will use joins to get data from multiple tables. So first raw data, then data models, then application. Guess what? With Cassandra, it goes exactly opposite way. No, but real, in the exactly opposite way. Actually, not only with Cassandra, because it goes for all the most of the other NoSQL databases. You first think about user behavior because customer first, and we think about how exactly customer is going to use my application. What will be customer workflows? I will explain it in a bigger detail soon. When we identify workflows, their dependencies and needs, dependencies of not the entities, but dependencies of the workflows, you will see soon. When we define queries to fulfill those workflows, and knowing the queries, we will design tables using denormalization. And we will use batch when inserting or updating denormalized data of multiple tables. So, ladies and gentlemen, welcome to data modeling methodology developed by amazing Dr. Artem Chibatko. And we will discuss modeling process step by step. So, Stefano, do we have any good questions or points to discuss?
Well, there is a question I've been partially answering, and also David chimed in about denormalizations, because, you know, as always happens, that surprises many folks, and it is indeed a surprising idea in a sense. So they ask, what happens if there is a department name in one table that is just not present in the other one? So something that the relational DB just does not let you do by design. So, well, the answer is multifaceted. It depends on the application, what the application does, how the data are accessed and combined at the application or API level at least. And there is not a single answer, I would say. So it might be just that it's not a problem, and some rows in one table just remains there, stale, never, right? And maybe there will be a cleanup task from time to time. And sometimes this is really might even be part of the design in a sense. Other times you have to ask yourselves, how come my application brought the DB in such an inconsistent state, so to speak, such a puzzling state? And there might be a bug in the way you handle your writes, for example. But there are also tools to keep that into check, such as batches or even periodic Spark jobs, for example, to check for such weird situations. But really, it's really depends on the particular case. But yeah. So normalized databases do not offer that kind of problem by design, but you pay a very high price that is a performance wall. And in today's world, you just can't afford that. That's more or less the gist.
There are some questions I want quickly to answer. First one will be, wait a second. Is there a limit on number of columns? I believe there is a limit of number of columns, but it's quite high. I don't remember a particular number. Ahomem asks, is schema evaluation support? So there is alter table, alter key space tables, statements, and I even work right now to make them a little bit more convenient to use. But schema evaluation statements, alter table statements, and so on, much more limited than you use it to have. So you cannot use you cannot change partition key, you cannot use clustering columns. Basically, you cannot touch all the parts of a primary key. And let's think about that. Partition key defines how data is distributed over the cluster. Clustering columns define how data is stored on disk. Changing any of those parts would lead to what? If you change a partition key, your data has to be reshuffled all across the cluster. And working with Cassandra, you have to start to thinking in the dozens, hundreds, thousands server size. You do not want your cluster to reshuffle data over petabytes, over 1,000 servers. So altering partition key is not supported and not allowed. Meanwhile, clustering key defines storage on how it's stored on disk. Changing clustering keys will lead to restoring all the data in your cluster or of the table, rewrite basically back on disk in the new order, which is again which will paralyze your cluster for quite some time. You don't want to have it. So alter table present, but it's very limited. You can change basically only data columns. Data columns is not something what affect your partition keys. First thing. Second thing I wanted to answer, Jitesh asks, can you give some example use cases for materialized views and secondary indexes if time permits? Time won't permit because we are focused on the more fundamental things of data modeling. Materialized views are experimental, so at the moment in the current state, they aren't really recommended for production use, although I know a couple of success stories with them. And secondary indexes are covered in DataStax Academy courses, so you will be good. And Sajal Goyal says, we think in reverse in Cassandra. And yes, totally right. In Cassandra data modeling, we think first not on the raw data, but we think of the customers and what we will do with our application. If you have heard of things like user stories, like as a customer, in order to pick right goods for me, I go to catalog. User stories. If you have heard of this designing approach, it's very much matching the Cassandra data modeling. Okay, so let's go, and we have more things to cover today. Data modeling process step by step. Data modeling methodology includes 4 ideas and 2 steps to join them together. First one will be conceptual data model, and second one will be application workflow model, and third one will be logical data model, and fourth one will be physical data model. So far, it sounds a little bit puzzling, I know. So let's go and walk through that and discuss every step in the bigger details. First, you have to understand the data and identify access patterns. What that means? First, understand the data. We still have to think about the data we have, about the entities, their properties, and relation. It's still present. But The thing what also we do at the very same time is we identify access patterns. So basically, we analyze customer workflows as we analyze the domain. Then joining them together based on the analysis of our result, I will show it in the bigger details with example. So don't hurry, don't ask your questions. Wait a moment, pay attention. We bind them together using the query first approach. Based on the results of the analysis of a domain and of the workflow, we design queries. And as a final result, we optimize them, bringing some nice Cassandra optimizations we have, and we can create tables after that. Design is done. Data model is done. It still sounds puzzling, I know. So let's go practical. We will learn by a real use case. In this case, we will learn how to create an efficient data model for global temperature monitoring sensor network, which kind of relates to what we did before, but now with a real SQL code. We cover conceptual data model, application workflow, logical data model, physical data model, final SQL schema, and query design. It will be our IoT Internet of Things case. So I want you to think a little bit. First, we analyze the domain. And what is the domain and what are the entities we have in this sensor scenario? Take a look. We have sensor networks, we have sensors, and we have temperature measurements. Each network of sensors has a unique name, description, region, number of sensors. Name and description, region are text type, and number of sensors is integer. If we are lucky enough and no one crushes our sensors into two halves. What is a sensor? Sensor belongs to a network. Sensor has a unique ID. Sensor knows its location in this scenario. It knows its location. It's programmed for that. Some characteristics. And temperature measurement has timestamp and value. And one measurement belongs to one and only one sensor. Network can have multiple sensors. Each sensor belongs to only one network. Each measurement belongs to one and only one network. That must be quite simple case for every with the real software development experience. Networks, sensors, measurements. And what do we do with these domain definition? We go and we create entity relationship diagram based on the data we have. It's a typical entity relationship diagram. If you know this format, you already know what's going on right here. We have three entities. Network. One network has multiple sensors. One sensor records multiple temperature measurements. That's it. Three entities, two relations between them. When each network has name, description, region, number of sensors. And each sensor has ID and location. Location consists of latitude and longitude. And each sensor has some characteristics. Those may be different from sensor to sensor, by the way. And every temperature measurement has a timestamp and value. Let's stop here for a moment and think a little bit. That's our entity relationship diagram for quite a simple use case. But it describes everything what we have. Network has sensors and sensors records temperature plus some properties. This entity relationship diagram should look pretty simple to you. I hope so. We discussed the domain, but it's not enough. Now, as a part of the first step, because they can happen in parallel, we decide application workflows or usage scenarios. And let's think of the application workflow for this story. Application workflow has an entry point task. Show all sensor network. What is an entry point task? You will see in a moment. show all sensor networks. This task requires querying a database to find information about all networks and show those networks. Next, given a customer has a list of the networks or a user of our system, he or she can click on one of the networks and we can show all sensors in a selected network, or there is also must be a button to show a heat map for a selected network when we have to show a heat map. And finally, later, going away from display or sensors in the network, customer or user can click some particular sensor and see the story of raw temperature measurements for a given sensor. Those are usage scenarios we discuss. At the moment, we won't discuss writing data, but only reading data because it's essential for us. And we get to 4 cases. Find information about all networks, order by name ascending. It's query 1. Then query 2, find hourly average temperatures for every sensor in a specified network for a given date range. Then find information about all sensors in a specified network. And finally, find raw measurements for a particular sensor on a specified date, order by timestamp, descending. We have Q1, Q2, Q3, Q4. And now let's get back to this entry point task. What is an entry point task? You maybe remember, I've mentioned it before, what workflows have the dependencies, like your packages, like your libraries, like your applications has dependencies to some other libraries, to some frameworks maybe. Workflows also has the dependencies. Take a look. Can I execute query 4, find raw measurements for a particular sensor, without executing any of the queries above, query 1, 2, or 3? Can I or can't? What do you think? As always, answering the YouTube chat, please. Cannot, no. Okay, looks like you got it. Can't, right. In short, in the simple scenario, answer is no, I cannot. Why? Because I simply don't know sensor ID. And sensor ID is essential if I'm going to store data for a particular sensor. I need to know this ID. You see, if I don't execute any of the queries above, I cannot execute it because I do not know sensor ID. And we just realize it, but where is the dependency? On which query Q4 depends? Query 4 depends on Q3. Find information about all sensors in a specified network. But question is, can I execute Q3 standalone without no data? I mean, with no previously executed queries? No, again, because I do not know what sensor network name. And now we find out what Q3 depends on Q1, find information about the networks. So that's why Q1 is in our entry point task. And now take a look at the application workflow diagram. That is our application workflow diagram. Those are our data access patterns. We defined it already, but now with dependencies. If I want to show raw temperature values for a sensor, I need sensor ID. I get sensor ID when I display all the sensors in a network, but I cannot show all sensors in the network if I don't know network ID or network name. And we get to entry point, and entry point is Q1, show all sensor networks. And that's, ladies and gentlemen, application workflow diagram. And it's not less important than entity relationship diagram. They both matter, and they both are very important to us. So we discussed the domain, entity, I describe it by entity relationship diagram. And now we discussed application workflow as you write down as an application workflow diagram. For the homework, by the way, it's optional, but I do recommend you to sit and write down those diagrams just by paper and pen as an exercise for your brain. It really helps you to set up your mind in this way. But it's optional, but you can make a photo and send to me. I will be totally happy. Now we have to map those ideas together. And first we do thinking of those workflows and thinking of these data, we map them together, and applying very first approach, I just sit and start to write queries. Tables don't exist, but I already writing select statements. And for query one, it can be something like that. Select name, description, region, number sensors from networks where bucket equals all. And this part of a statement, select name, description, region from networks, may sound very familiar to you, right? But bucket equal all is a little bit not clear. I will explain it later. And for the Q2, show all sensors per network. That's Q2, which belongs to heat map. We can go with selecting all the data required for our heat maps. And then based on the queries, I won't show Q3 and Q4 because they are very simple and you will see them in a moment on your own. But we get to the next step of Cassandra data modeling methodology, which is logical data model. And we write down logical data model in so-known Chibatko diagram. And Artem Chibatko is the developer, creator of the data modeling methodology and our colleague, which we are very proud of, by the way. So when we start to bring them together, you see it's still the same workflow map, Q1, Q2, Q3, Q4, but now we've, as a part of Chibatko diagram, we see also the database tables we are going to use, and one will be networks, sensors by network, temperatures by sensor, and so on. So we see one. Q1, we get networks. Q2, we get sensors by network because we know network name. And Q4, we get sensor measurements because we know sensor ID from Q4, results of the Q3 result. And you can see it, table name, so query name, table name, list of the fields, and partition key, or in this case, sensor by network, partition key clustering column, or in this case, we have even 3 clustering columns in different order per network. Or here, partition key, as you see, uses familiar bucketing. Sensor and they together, partition keys, they build compound key, and as a result, we have compound partitions with bucketing. And final step based on that will be to apply some optimizations and explanations. Here, first of all, let's take a look at the temperatures by sensor measurement. It will be very easy. Sensor ID is just type text, or it may be UUID, doesn't matter for us. Date is a date type. Timestamp will be clustering column with timestamp, and value is float. That's quite simple. Then sensor by network. Network text partition key, sensor text partition key, latitude decimal, longitude decimal, and characteristics is a map text. So every sensor may have multiple different characteristics, and one sensor may have, I don't know, some they may have different types, different sets of characteristics. It's flexible. And finally, here we have name, description, region, a number of sensors. That is simple. But what is a bucket here, and why it's a clustering partition key? Where did we get bucket? Take a look. If I try to get networks without adding any bucketing, I will have to do full cluster scan, because if I don't have bucket for all my networks, well, then I will have to ask the full cluster scan all my servers, give me data, give me data, give me data. That's not sound good. Then there is a practice of those buckets. As I'm not going to have a lot of sensors, a lot of networks, at least in the beginning of my project, I create a bucket all or bucket default and put all my networks there. As long as I have, as every network is small, just like description, name, number of sensors. I can have a lot of them within same partition and have no problems. If at any point I will start to have millions of networks, I will have to rethink my data model. But at this moment, put all networks in the single bucket is totally acceptable. And finally, that's what this bucket makes. And now, based on this physical data model, we are doing very last step. We just write down those physical data model in the SQL statements. So it's going to be very simple. Yes, the DDL statement for networks. That's my network. Bucket, partition key, name, clustering, column, description, region, number, sensors. Here we go, create table networks, bucket text, name text, description text, region text, number, sensors, int. Primary, bucket, name, and bucket will be the same for all the networks. In the beginning, it's totally fine. Statement for sensors by network. Network text, sensor text, latitude, longitude, decimal, characteristic, map, text, primary key, sensor by network. Network is a partition key. So you see, when you reach this physical data model, you have nothing to do to put that into SQL. It's very easy. Good. And now one last question, and I give the microphone to Stefano. I want you to think the very last moment today before we go to practical steps and before we go to quiz. Imagine we together, all of us were just hired by YouTube. And we have to design a data model for the comments because something very bad happened and YouTube doesn't have comments anymore. And we have to decide for a new data model for the YouTube. And I have very simple question. Let's take a look. Well, I don't have to explain what is a YouTube comment because it's a very simple case. It's just a comment per video. One video can have multiple comments from different answers, from different authors, right? By the way, thank you so much for warm feedback. I was looking for a picture to explain the comment story, and I was just got a wave of love right into to my heart. It's just amazing how you guys commenting our videos. Thank you so much. So, and we are designing. Now, please pay attention because it's a question and you will have to answer. We have to decide for a data model for 3 particular use cases. We have to show comments in a very simple scenario. Some user opens a video. Basically, we have to find comments related to this video using its identifier, most recent first. Then user opens a video page. Do we have a video page ID? Do we have a video ID? Yes, we suppose we do, because the list of the videos was shown already, like YouTube suggestions, for example, right? So workflow 1, find comments related to a target video by its ID. And we have 2 more use cases. User opens his own profile, or moderator opens some user profile suspecting this user in some spam, or I don't know, whatever, publishing bad comments. So maybe user must be suspended or something. And it brings us to workflow 2. For the workflow 1, for those 2 use cases, find comments related to target user using its identifier, most recent first. For those use cases, do we know target user ID? What about our workflow dependencies? We expect we do. If user opens his own profile, he must be registered already, therefore ID is known. Then moderator opens a user profile. That usually means what he has got a report to some particular comment, or maybe anyway, he got some user, therefore ID is known, correct? So we have workflow, find comments related to target video, find comment related to target user, get most recent first. In first case, we show all comments per video. In second case, we show all comments related to target user, even if those were written to different videos. So query 1 must be looking something like find comments for a video with a known ID. And second query will look like find comments posted for a user with a known ID, most recent first. Now we are getting to the real question. How many tables we will need to serve those requirements and to fulfill those two queries? I need some tragic music at this moment, right? How many tables we will need to serve those requirements? Do we need to have more than one table? Do we have to apply denormalization? 3, okay. Partition key video ID plus, okay.
4 tables.
3, 4.
3, 2.
Okay.
Well, nobody
Okay.
says one table, so that's one table is
already,
wrong.
So nobody says
one table is not enough. Oh, I see one.
No. My MK,
For
one
sure,
table is not
one
enough.
table is not enough. That's one point.
Yeah. I see what was the misunderstanding. Videos
Yes.
table exists
Yes,
already.
sorry. How many tables with comments do we need? Let's
for
say.
comments. I will write it down and I will fix the slide.
I think Youssef wrote a very clear answer.
So, yes, the normalization is needed, and considering videos table exists, we will need 2 tables. So if you answer it 2, counting comments per video, comments per user, or if you answer it 3, counting videos, you are right. And if you answer it 4, meaning videos, comments per video, comments per user, which is also maybe right. But for the comments point of view, the minimum amount of the tables we will need is 2. Select all from comments by user, the user ID, and select all from comments by video, the video ID. Because don't forget, you always have to specify explicitly known partition key. And in case when we query by user, we do not know video. In the case where we query by video, we do not know users, as long as YouTube has more than one user. And I expect that to be the case. So the answer is we will need 2 tables. And if that's what you needed, if it's that's what you answered, you just gave me the right answer, and you are amazing, and you are the best. You know what, Cedric? Oh, sorry, Cedric. Well, you know what, Stefan?
Yeah, tell me.
It's now your turn.
Yes, very good. So I see Youssef is leaving now, so he will not attend the quiz next time. So we will try to fit better into the time next week. But that was very important example. So sometimes you need 2 tables with the very same rows, just so to speak, arranged differently to support different queries. That's a very typical pattern. And well, that's one of the important lessons. Let me now.
I'm sorry,
yes.
Stefano. Before Youssef leaves.
Yes.
First of all, thank you for answering. And second of all, ladies and gentlemen, I see almost 150 people watching us now, but we have only 60 likes. That is not serious, and no quiz happening, no homework happening. As long as we won't get higher number, you stayed with us for 2 hours, and mostly probably that's your second workshop, so we do deserve a like on YouTube. You know what to do.
Oh, now the number is increasing a lot. Great.
That is something. That is something already.
That's more like
I know we are
it.
doing a good job.
Okay, so there's a question about the list of best practice for modeling. Well, that's more or less what we are trying to cover today. Obviously, we can just touch the surface, but well, maybe Alex, you can put a few links on the chat more in depth. But now, you know what? Sorry.
Yeah, first we have now more than 100 likes, and that's something
great.
What I really like. Thank you so much. Our team is very happy. I mean, you see 2 of us on the screen, but there is like 10 people working on this bootcamp. So thanks to you from all of us. And second point, I believe, yeah, because we have more than 100 likes, we can proceed.
Yes.
And third thing, regarding the links to data modeling and best practices and so on. in the third and fourth weeks of this bootcamp, you will learn at DS220 data modeling course at the Academy. The X we gave you today was a quick overview. We cannot put all the Cassandra data modeling into just 2 hours. It's much bigger than that. But we have a full, free, totally open for you course at theacademy.datastax.com. And it's a very essential part of the preparations for the exam. You get this course, you will be ready to take the exam. So you will get your links in the third and fourth weeks of the bootcamp.
Yeah.
We are ready to move on.
Yes. So let's move to the practice part, because there is a small part of hands-on for you. But to do that, first okay, now it has already flowed, it has gone by. Oops. But maybe I'll ask Nightbot to paste again. So there is a link in the chat, but I better paste it again. There is a link to the YouTube repository where you would find more resources about today. Maybe I better switch to my screen so you can see it directly. And there we go. So this is the repository for the bootcamp. You know that already if you were here last week. Now I am in the folder week 2, data modeling. And again, it's an alarm going off. You can see here in this README, there is a brief recap of what we've been seeing. You can download the slides. So there are a few links, and there are also instructions about the homework and important announcement about the homework. We are grading them, and there are detailed instructions on how to overcome a problem in using virtual machines that we've been made aware of, and also some tricks to make everything work. So please keep an eye on these homework instructions, because they will be giving a detailed, updated instructions to make everything work. But this is for the academy, for the course part, because homework for today will be the second part of the DS201 exercises. Okay, now so in this README there is a recap of the data models we have been seeing so far. But what's important for today is I assume, okay, so I know many of you have been with us already last week, so I will assume that you already have an AstroDB account. And but if you don't worry, because there are instructions here to create yours. But I think, Alex, we are a bit short on time, so maybe I can just go through. I can go in demo mode and just show you what we should be doing. So please refer to the README for instructions. Those of you who were with us last week know what I'm showing now. I am showing my my AstroDB interface that shows my database called workshops. And in this database, I will create a new key space, which is a very quick operation. Again, maybe I switch to smaller heads for us so you can see better. So there, this small demo is also useful because it will pave the way for next week's, because next week you will start building the application, and it is a small to-do application that you will write from the start. For that, we might already go ahead and create the key space that will host the very small data model needed for that application. So I just created a key space called to-dos. You see, it's here, and it's just created, made available in a few seconds for me. Again, we invite you to go through the instructions and to get some more practice, but now I'm just demoing it for lack of time. So I have my to-dos key space, and I can go to the SQL console that you know already, probably. I go to my SQL console and get it ready. So now if I do desk key spaces, tell me all key spaces that are there, you see there is this new to-dos that I just created. Okay, so with that, I'll go back to the README, because we start thinking of the data model, the table needed for this to-do application. This is preliminary to next week's application. So it's pay attention, please. It's a very simple data model compared to what you have been seeing so far with Alex, but still it requires some thinking, and it is a good example of how to go about designing a table. You will be creating a standard, let's say a standard sample to-do application that shows a list of to-do items for a given user and make it possible to tick them as done or leave them as not done yet. So you will be able to add, delete, and edit individual items. This will be per user, so you will have your own user space to access your list of to-dos. So basically, that's it. So it's a simple application, and indeed the corresponding data model is very simple, but still, it offers some thinking. So every to-do item will have a title and a Boolean flag whether it's been completed or not, and that's a given. So title and completed are probably obviously going to be columns in this table containing the to-do items. But that's not the end of it, because every item probably will need a unique ID to be able to distinguish them and to identify them for later deleting or editing. So for sure, we will need an item ID, something like a UUID that you've seen so far, the unique ID of almost guaranteed unicity. That's not the end of it, because we would like this application to be able to support several users at once, each one with their own list of to-do items. And that's a very good candidate for partitioning. But let's say that every to-do item has a user ID. So my to-do items will have my own user ID, and Alex's to-do items will have a different user ID. That is how many users can use the same table and still get each one their own individual list of to-do items. Okay, so that's more or less, in this case, that's how it goes as far as identifying entities and their attributes, because there is a single entity with 4 attributes in this very simple case. Now let's think of the application workflow. Now, maybe this is something you didn't appreciate enough, but this is the screenshot of the main interface of the application, and this is what it lets you do. It lets you access and view all of your to-do items at once, and that's simple, but still is a good hint, because it means that I have to support a single workflow, basically, which you can see here. Application access pattern 1. User wants to see all of their to-do items. So I need to think of this as my only query, and the query would be get all to-do items for a given user, which is identified by a user ID. That is basically very quick and easily translated into a proper SQL statement. So it will be select blah, blah, blah from to-do items where user ID equal, let's say, John, whatever, right? So this is the query I need to support when thinking of how to build the table. Other operations such as deleting a single to-do item or marking it as done, or even just editing the title, they are not so important when designing the table, because they will be accessing a single row anyway, whatever the exact way it is designed. So this is the only important query when thinking of partitioning, basically. Okay, so this is a very simple, quick example. How do you get to the logical data model? Well, again, there are a series of steps very quickly. We need title and completed when we want to get our to-do items back. That's because the UI of the application wants them. And that's one thing. But the next step is to look at what is in this where clause. If you look at the where clause, you realize that user ID has to be part of the table for sure. And it has also to be the partitioning, because you see here, I want to get all to-do items for John with a single query. So I have to partition by user ID, so that all to-do items by John will be together in a single partition, and I can do a single query. Very good. Obviously, uniqueness has to be taken into account. So I have to think of item ID as part of the table. Otherwise, I would be not able to guarantee uniqueness of the various entries. And that's about it. So item ID, we might use UUID, but we choose to go, and that's an anticipation of the physical data model, we choose to go with a time UUID, which is just a slightly different way of having a unique ID, which has the advantage of being time orderable. So we decide that within the partition for a given user ID, we want to sort by item ID ascending. So we get the earlier items first, why not? And we are at a very simple case of Chibotko diagram. So these are the four fields, the four columns in the table, and user ID would be the partition key, as we discussed. Item ID will be the clustering column in ascending order. The next step, as you have seen already, would be to go to make this into a physical data model. Well, in this case, there are not many optimizations to do. It is just about assigning data types, basically. So let me skip this part. You can read that in the README, but basically user ID will be a text because we like to have it in clear text. Item ID, we decide it's a time UUID. Title is a text like walk the dog or whatever, and completed is a boolean, and that's it. So that's very quickly becoming a create table statement, which I just want to run in the SQL console here. Oh, sorry, I have to first use to-dos in my SQL console, right? I run the create table and the table has been created. How can I be sure? Well, desk tables, to-do items.
It's a Linux way. If you have no error output,
yes,
that means it's good.
Yes. Desk table to-do items, and I will get back the full create table statement plus all of the settings, which by default are attached to the table in SQL. So this is all good and nice. Now I will just show you that this is a table that works, but I will do that very quickly. You see there are some sample insertions that one can run here just to see that everything works. Actually, if you care to have a closer look at what is done here, you will basically do a typical operation that happens when you are designing an application, which is you are trying out with SQL what will be the future commands, the future data access patterns that you will embed in your application using in the code. So now I'm typing explicitly select splat from to-do items where user ID equal John. Very good. And this is basically, this will be one of the very queries that my application will do, and that you will see next week, basically. So this is how I get all to-do items for John, and just to check that this works and it is compliant with the requirements of the application and with the partitioning. I think with that, and you are invited to do that, so you have your table already there for next week. I think with that, I can close. Just one mention. In section 5 of the README, there is, it is spelled out in all the details what is the data model that you are required to approach and to try your lab with as part of the lab for next week. So there is a particular pattern of query and dependency between queries, and you are required to think about it and design a proper way to create the tables supporting this flow. The Google form will be available as soon as we close, as we are over with this live. So Yeah, at the moment it's still being kept closed to keep you focused on this, but we will open it as soon as we are over with today's live. Okay, so I think that's it, Alex. So we can jump back to your screen or directly to Menti, maybe.
We go directly to Menti. There is no need to switch
Very
for
good.
my screen for a second.
So quiz time.
Yeah.
And maybe I can make us become big again. So quiz time. Be ready. Keep your reflexes oiled, because now every answer has to be not only correct, but you have to answer fast.
Also fast.
Okay,
great.
So we
and
can.
Maybe you can turn on the music and make a full screen.
Yes, absolutely. If I know how to make full screen, that should be.
Just browser full screen on the right top side. I know you are not a Windows guy.
I'm not.
Can you imagine the sacrification of Stefano? He agrees to use Windows to run these, to host these workshops.
Yes, I'm very not familiar with Windows, but technical reasons make me. F11, thank you. I was about to get to it, so I made it. Thank you. So I think okay, I'll show the joining windows a little more. So please join us again on Menti. Yeah, I agree. My Windows is very strange. Every time I boot it, it syncs to a different time zone for some reason, but I don't know why. Okay, so let's start. Quiz time.
Right.
Okay. So let's give.
Just wait a second. I see we have 122 people watching us now.
Yeah, but
I see.
Now we are
now
back to numbers. Yeah, it was, I think, a glitch of my refreshing whatever. So we can start. Question number 1.
Not a problem.
In the data modeling framework, we start modeling with the conceptual data model, followed by application workflow, with the physical data model, with the logical data model, or copy pasting from Stack Overflow. So what are or what is the first step or steps to approach data modeling in Cassandra? Let's see.
I love Stack Overflow, but in this particular
case, not much help.
Yeah.
So I see many of you gave the right answer. That means Alex did a great job. And let's see.
And physical data modeling is the last step of data modeling framework. So So Leeds was the fastest one.
Great. Okay.
Great job.
Obviously,
Congrats.
Still the beginning, and let's move on. Second question. Denormalization means the same as schemaless, or maybe it means that you can overwrite rows in a table, or it means that the same piece of data goes to several tables, or it is the same as in relational tables. So denormalization means, I remember at the beginning we had this question. Now let's see what changed. And I see that most of you gave the right answer. So yes, denormalization means that you can not be afraid of duplicating data if this makes your application go fast. Let me phrase it this way. That is fun enough. Very good. Let's see. I guess many of the first positions gave the right answer, and that's the case. But who was the fastest? I think Antonio was the fastest, and he jumps in third position. So Liz, Taz, and Antonio. But it's a close call with the other.
He's keeping the first place.
Yes. And let's go to the next question. Let's see if you paid attention. Okay, question number 3. Answer fast to get more points. What columns together define uniqueness of rows? Clustering columns, or maybe primary key columns, or maybe partition key columns, all columns of the row, or maybe the combination of partition key and clustering columns. Let's see. Now we are speaking about uniqueness in a table. And time is up. And let's see. Yeah, there are two possible right answers. That's because they are two ways of saying the same thing. And that's the right answer. I see most of you good enough gave the right answer. And that means...
Option 2 and option 5 are basically the same.
Yes, absolutely.
Primary key is the partition key plus clustering column.
I hoped to confuse some of you, but you were too smart. So fastest and jumps in first position.
Yeah, Arturo and Taz are doing the answer the very same millisecond.
Yes,
that's amazing.
Yes. Now question number 4. Let's see. A good rule for partitions. I think that's a bit easy because we've been speaking a lot on that. Enable partitioning only when necessary, or store together what you retrieve together, or make them as big as possible, or maybe make them as small as possible.
Well, I'm not sure about the right answer, but if you make them as big as possible, I will come for you. As a NoSQL police detective.
Okay, I see. Store together what you retrieve together.
Hey, take a look, we have one criminal.
Yeah. Okay, about make them as small as possible. That's not entirely wrong in a sense, but you might exceed and make them so small that they will not support your queries. Think about getting all commands together. If you make...
Right, you have to think not only on your writes, but also on the reads. And when you are doing reads, you have to specify all the parts of a partition key. Yeah. So don't make them as small as possible. That also makes no sense.
Yeah, and you will not have a working query, maybe. Sorry.
Right. And you cannot enable or disable partitioning when necessary. Yeah. Partitioning is enabled by default and cannot be switched off in Cassandra.
And once you choose a partitioning for the table, it's forever. So think carefully. Okay, so let's see. Okay. Liz, again, fastest and jumps in first position.
Great job, Liz.
Great job, and let's go on. Question number 5. Answer fast to get more points. Again, rules for partitioning. Let's see. Each query should reach a single partition. Keep them below 100 megabytes each, more or less. Evenly distribute write load or avoid ever-growing partitions. Let's see. Give an answer, think about what we said, and try your luck. And time is up. Let's see. Ah, very good. An even distribution of answers because they are all correct. Ha ha ha. I caught you.
Perfect.
Very good. So they are all good answers, indeed.
Yep. There is no big trouble if your query hits 2 or 3 partitions, but in general, of course, we recommend to design your partitions and queries the way what each query will reach one partition. It maximizes the efficiency. Hey, and Liz is fastest again.
You know what,
How Alex, do you do that?
We thought of confusing players with this question with all correct answers, but I think our guys here have been paying too much attention for us. So very good, everyone, and let's go. Question number 6. Answer fast to get more points. How do you run a join in Cassandra? The answer is, oh, you don't, or with a join clause in CQL, or it's automatically done for you behind the scenes with a join table handled by Cassandra itself, or you need friends in high places. Let's see. This is also something we discussed at length, and the answer is you don't, because there is no join clause in CQL, and there is certainly, Cassandra has no will to do that secretly without you knowing.
Don't forget, Cassandra is non-relational database after all.
Yeah, so
there is no joins.
No joins, no relations in the relational sense. And the answer, okay, so Liz again, he's the fastest and he maintains the first position. I see some movements in 2nd to 4th position, and there's still time to scramble the leaderboard with the last two questions. And let's see.
Please, do you know we are hiring?
So, clustering columns when querying. You must specify all of them, or you must specify all or none of them. They support inequalities only, or if you specify the first ones, it's okay. That's tough, maybe.
Yeah, that's not a simple one. We didn't discuss clustering columns in too big details, so...
Yeah, so the right answer is the last one.
Oh my! Oh, that's going... You know what, now I'm a bit scared to turn the page and see on the leaderboard. We will have a wipe.
So all must be specified is certainly not right, because you might want to get the whole partition. Why not? That's a supported valid query pattern. So, but I think many of you here in the top leaderboard gave the right answer, and Liz also maintains the position. Very good. Well done. That was a hard question, but you were able to withstand it. Last question. Da-da-da-da.
It will decide everything.
Answer fast to get more points. If you have the same rows in two tables, that means that there is still some optimization you can do, or that is a typical outcome of a proper data model, or it is something to be avoided absolutely, or it means that one table is legacy. Maybe it's there by mistake and can be discarded, garbage collected. So let's see.
Few seconds to go.
Time's up. And it is a common outcome of a proper data model. Think about the comments in the YouTube clone. Comments by video, comments by user, that's absolutely right. It is the same set of rows, just arranged differently.
Yep, I believe I know this distribution and answers. The story is there are some people who understand the benefits of denormalization, but still didn't accept it by heart, only by brain.
Embrace
and then
denormalization.
When you are small on time, when you are in a rush, your heart answers faster than brain. So these two same rows into different tables is a common outcome of the denormalization. And denormalization is a common output, a common outcome of a proper data model. It doesn't mean you still can optimize the data model. Optimize for what? There is no just optimize. There is optimize for writes or for reads. So this answer is wrong and to be avoided at all costs.
Not necessarily.
We discussed it. Yeah. Denormalization and normalization. The real life is not like Star Wars movie where you have amazing light side of a force and dark side of a force is always bad. Real life is not like that. And denormalization is good as long as you keep it under control. Denormalization is bad when it keeps you under control. Then it's bad. But as long as you keep it under control, it's your friend.
Okay, there is a comment in the chat by Adriano. So same rows is different than same piece of rows. Yes, that's right. But even there might be some cases, and there actually are some cases where you really have the same rows with the same columns. So the same table with the same columns, just a different partitioning. And that's a case that occurs. So even the comments by video and comments by what was that user, they most likely have the very same rows, columns and rows, just differently partitioned for different access patterns. Okay.
Right.
Let's see the final result.
Who is the winner?
Who is the winner? That's interesting. And
oh my God!
I'm sorry,
Adriano.
I'm
sorry, Adriano. Lost the last chance.
Liz maintains the leaderboard. Talib and Arturo second and third. And now, yeah, sorry, Adriano, but we are here to learn more than to win prizes. But anyway, there's next week, right? So.
Yeah, you still have 2 more weeks to win.
If I remember well, I added a command here. And yes, so the first, second, and third position, please write an email to garyharvey@datastax.com. You see that in the YouTube chat. And please take a screenshot now with your phone or with your PC of the winning screen on your Menti. So take a screenshot.
If you are,
Sorry.
yep.
And get ready to send it to Gary Harvey to claim your prize.
Right. And what I wanted to say, we do congratulate Liz, Talib, and Arturo. First 3 places is a great job in this quiz. And we do congratulate all the people on the leaderboard. Even if you didn't win the prize, you still finish it in the top 10 of actually many dozens of people, almost, I believe, even more than 100 of people in the beginning, at least. And that is amazing. Like, you did a good job. And even if you are not on the leaderboard, you have something to be really proud of. You participate in our bootcamp, and that is the 2nd week. And every next week, you get better and better, joining our Learnery, like January, but for learning. And that means what in the end, you will get a real prize, knowledge, which makes you better engineer, better software developer, or whatever your job is. And that's what really matters. Thank you for coming.
Yes, very wise words. Now with that, I will go further with the Menti because we have a quick survey that I will leave open. We would like to get some feedback, some free form feedback. And please, if you have something to tell us, that's the place. But in the meantime, while this is working, I will go back to Alex, your screen for the last slides. Okay, great. That's good.
Hey, very so warm feedback.
Yes, yes.
Thank
I
you.
see
Okay,
feedback.
so finalizing these things. First winners, first, second, third place, send your screenshot and send a message to gary.harvey@datastax.com. Include a screenshot of your Menti. And congrats. Then homework. Homework is available on !homework. Homework. You have to complete, it's all explained on GitHub. You have to complete DS201 course, second part, because first part we did last week. And if you miss it the first week, you are going to have quite some time learning, but it's for good. Cassandra is in high demand, and this demand will only grow. And build a data model with Cassandra, as all explained on GitHub. Now, next thing. Next week, we will work with application code, and we will build a full stack application with Apache Cassandra using Java or Python or JavaScript. That's for you to decide. We support multiple languages, as you see. And if you are not so good in any of them, don't worry, because you can just use code we give and you will be fine already. So even if you are a complete beginner, you still can make it. Join our Discord community, which is getting to the magic number of 20,000 Discord participants. It's a great Discord server, and you will have very experienced developers there asking and answering questions. So jump into Discord and ask questions there. Don't forget to subscribe to this channel, because we have more than just this bootcamp. We have more content for different kind of developers and engineers. And that was Stefano Lattini, straight from Italy, and Alex Volochnev from Germany. We are happy to spend this time with you, and see you next week, or see you in Discord.
Yes.
Don't forget, for your friends, it's not late to join, and they even have chance to jump in for the second week live stream, which will happen for us, it will be tomorrow morning.
Yeah.
And your time, when please find in the bootcamp description.
Yeah. So it's been great. Thank you for attending and for being with us so far. And with that, I think we are done.
Yep.
See you next week for another chapter.
See you next week.
Bye-bye.
Or see you in Discord. Thank you.
Bye.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
A being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.